Hey, this is Daniel, and this is a quick demo of the order to randomness patch example in the pymax examples folder. This is my Python module called pymax order to randomness, and this is my max patch of the same name. You could see from the beginning that we're going to use a little bit of Markov chain stuff here for the melody. So these are the Markov helper functions. And then this is my melody, which is really just a Markov chain that steps through the pitch classes of a C major chord triad. It's really straightforward. You can see from the state matrix of the Markov chain that it's just going to repeat itself, going from the first note to the second note to the third note to the fourth note to the fifth note, with probability 1 each time, but we're going to be able to add perturbance to this Markov chain to make it move around. And we'll be able to do that in real time. Here are functions to set various stochastic parameters, like in the previous example, the stochastic texture example. Here's my set melodic randomness function, which adds a perturbance to different entries in the state matrix. So you can check that out and see how to do that. So a bunch of stuff that we can set in our melody object, and then the melody generator is really straightforward. We just get the pitch, velocity, duration from aspects of our melody object, and then we have this function melody advance, which you can see up here just moves everything through the Markov step for the melody, and then we add the on time, and that's it. This is adding everything. So I've actually added 4 different instances of the melody object, and I'm calling them M1 through M4, and then I've added 4 different instances of the melody generator object, and I'm calling them Gen 1 through Gen 4, and then you can see over here on my max patch, I have 4 different objects: PyObject M1, PyObject M2, PyObject M3, and PyObject M4, with a bunch of different things you can set for each of those that we saw in the functions: aspects of the velocity and the duration, inner onset time, melodic randomness, octave. Then over here I have my generators, and each of my generators takes, you can see generator 1 takes melody 1, generator 2 takes melody 2. So I've got the PyNote objects to play back the generators here. I've got the tempo lined up with each of them, although you could do different tempos for different generators actually. And I've got a pattern storage, so there's pattern 1 and there's pattern 2. So this is going to be everything sort of playing together, and this is going to be where I've cranked up the stochastic parameters of each of my PyObjects so that they're going to be playing back differently. Well, let's hear how this sounds. We'll start with order. I'm playing back through my Arturia pigment synthesizer. Kind of a jumpy but regular rhythm. Now here's randomness. What a funky groove. Let's go back to order. So it's repeating the same syncopated rhythm. What happens is that after it comes back from randomness, everything is sort of set in a different place. So it repeats based on where it's set, but it's not going to be the same each time. So randomness. Order. I'm going to speed it up a little bit so I can change the tempo here, which is cool. Randomness. you can set each individual element's stochastic parameters with its individual controls. So you see I've turned up the octave in M1. Can turn it, it's not too bad. Actually, it's kind of nice up high like that. So let's store that pattern with that high octave. And now I actually have a DAC which is going to animate the slider and turn it up and down, so we'll continuously move from order to randomness. So I think it starts at randomness. So let's check it out. So we're going to be interpolating between the order and randomness presets. So cool. There's some interesting little rhythms in there.